All right, folks, thank you for coming to this meetup. I just thought it would be a good topic to talk about. It is a knowledge graph, graph-focused meetup. So a topic I thought would be interesting for this meetup would be to talking about building a knowledge graph for code. Sorry, Peter, signal. Am I loud enough? Yeah. Okay. So we're all sort of familiar about knowledge graphs coming from a lot of it from Google when they started it to help power their search back in 2012. But it was more to do with what we call unstructured content, like text-based stuff, and that was an add-on to their PageRank algo. And so when people think about knowledge graphs, that's usually the first point that they go to. Now, before I start talking about knowledge graphs for code, I just want to give you a quick background about where I come from this. So I'm actually coming from a business background, right? My domain is risk management. I spent a lot of time in financial markets, that sort of thing. But a lot of the advice and the tooling and the stuff that I do is powered by data. It's powered by models, and that's how I've come down. It's what I call walking down the stack, right? So I'm starting from the business, going into the application layer, and definitely going to data because that's what powers the advice. And because I've had a couple of decades in this space, when we're building these sorts of models, it is very compute intensive, so we're talking about distributed systems, and my whole career has always been chasing compute. Where is the best place for compute to happen? Now, how do I describe myself? I'm just a cache junkie who walks up and down the stack. So where there's a problem to be solved and I have a skill set, sometimes I'm in the business layer, sometimes in the application layer, sometimes in the data layer. So that's a bit of the background because that kind of follows on to how I'm talking about it. A classic from the 90s. I want the truth about my code base. Well, you can't handle the truth because code bases are, when you come down, even for a lot of the mid-size sort of applications are quite complex. And then you add longevity to it. You have different versions. There's modifications. There's a different framework coming into the piece, and in a period of about 5 years or 6 years, it just becomes a whole big sprawl. And what we often find is that when that happens, people, when they add something new, they don't want to take it out because they don't know what's going to break. So this is a classic example of one of the reasons why we need to understand a code base and have a robust way of connecting all the dots together. So that's kind of where I want to talk about. So how I'm going to frame this is like, what is the problem that I'm trying here, okay? So let's just say, and I've framed this many times on social media, a lot of you, when you've started something new, you've walked in and you find there's no documentation. It's scanned, it's missing, you've got to find the expert. Okay, let me have a look at the code. Let me have a look at the repo. My goodness, it's a whole bag of stuff, right? Some of these things go on for thousands of files and hundreds of lines. Where do I start? So there's no easy way until you find somebody who said, okay, an expert, a friend, whatever, start here. And the worst thing about it is you're not given much time to get going. So here's the problem. What I need is a tool to search through the entire base to find out what do I need to change, and when I find what I need to change, how can I refactor it quickly? LLMs. Everybody knows vibe coding. I vibe coding. I mean, like a lot of the stuff you're going to see now, I mean, I don't write it myself. I understand what's going on. I know how to modify it, but I don't write it. But when you've got a lot of code How are you going to throw that entire thing into an LLM that says, can you please explain this to me? So we need a way to control the number of input tokens that go into it. So again, it comes back down to how do I search for what I need and to throw it in. So code, as I said, right? Code is connected, upstream and downstream. We need to understand that. And the other thing also is, okay, even if you find that little chunk of code that you say, okay, this is what I need, to understand, throw it into the LLM, explain it to me, and can you modify it? But you may work for an organization and you've got controls over it. There's governance, there's standards, all of that. How are you going to ask the LLM to control all of that? How much prompting are you going to try and do, or even fine-tuning? So that's a problem. So throwing things into the LLM, although it's it's great, you can do it with small chunks, but when you've got a code base, that's a problem. So what are we going to do? So one of the things that I wanted to demo for you today is a way to take a code base and just work with the metadata of code and then throw it into a knowledge graph. And how we're going to do that is with tooling, and tooling that helps you do it quickly. So that, and the other, it's not just quickly, but the other piece I wanted to impart is that when we start building knowledge graphs, we don't know, right, exactly how the end result is going to be, because we have to start somewhere, and then we start to build it up inch by inch, and we can go up quite quickly. Once we've got a picture of, once we've ingested the entire metadata of the code base in a knowledge graph, we can then start to carve out the little pieces of it, and then once it fits into the input tokens, a window of an LLM, we can throw it to the LLM and say, hey, can you explain a little bit of this? And I think the other more powerful thing is once we have the metadata in the LLM, in the knowledge graph, we can then start to do real software design and put controls over that metadata, and then say, use test-driven development to ask the LLM to write code for us, and there's a way to check what it did as well, and I'll come to that in a minute. So that's kind of like what I want to talk about today. And what I'm going to do is I want to show you a real working example of how this is done by tearing down an application. Now, the application I'm going to tear down is called Zotero. Before I do that, I've got this piece. How many people here are familiar with, let's say, graph databases? Is there a modular? Sorry. Yeah. So we're all seen something like that. That's the classic entity relationship diagram from a relational database. That's a fairly simple one. We can see that if we wanted, this is from Neo4j actually. They have a good example of this. If we want to see how a person is connected to the department, if all we get is the entity relationship diagram, we can see that, I need to go to the department, organization, and then department, or I can go from person to department member to department, or person, project member, project, department. As you can see, the relational database schema, with all its foreign keys, is great for the referential integrity, but the problem is it is not quite intuitive. You say, hey, what's the relationship between the person and the department? Same relationship here. If I pop it into a graph, that's what it looks like. Because a graph, right, same thing, right? So if you want to look at the dots, and now just table names. For the relationship, you're just specifying the relationship between two nodes, and the relationship, like in the relationship database terminology, that's just a foreign key, whereas in a graph database or using graph technology, you can specify the actual relationship that you're interested in. So you have one wire, but that one wire that connects the two can be called many different things, and it ends up being a lot of virtual connections between the two. This example, right? I just want you to hold on to this because there's in this, right? If I say, okay, that's how my data is stored. It's stored in a whole bunch of tables. But if I wanted to join person to department, and I'm only interested in that reference, what's the best way to join? You can see there's I mean, of course, joins are expensive, right? From a compute perspective. The easiest one, there's only 2 joins if you go through department member, but 3 if you go through any other route. So just knowing that all the relationships doesn't really tell you what is the best way to do it. However, when you pop it into the graph, immediately I'm just saying just join person to department, and it already knows how to do it. Now, this example that Neo4j uses, they are actually taking all the data from the relational database, and they're doing an entire lift and shift into the graph database. So that's why when you see all of these little, what they call properties, right, that's actual data. The paradigm that I'm talking about here is to only deal with the metadata of the relational database or any other data store, whether it's Mongo, key value, NoSQL, any of that, and just work with the metadata. So we're not pulling data across. We're not doing lift and shift. We're just working with the metadata of the database. So we're not, and that already will tell you a lot of things of what you need to do. I just earlier kind of interchangeably used the words knowledge graph and graph databases, and that's not entirely correct. Many ways to store a knowledge graph. There's graph databases, Neo4j. Janus has been around for a long time. They're open source. Tiger is one of the competitors to Neo4j. They're ex-Google. And then the other competing technology is RDF triple stores, like Wikipedia is powered by Blaze Graph. There's GraphDB, OntoText, big players. Stardog, Stardog is Accenture. And there's Elasticsearch. You can use Elasticsearch to be a knowledge graph. Many ways to do it. And you can also use a relational database to be a knowledge graph. And that's how Facebook had it for many years, and they had it in MySQL. So kind of like the reason why I'm going to split it out, because I really want to talk about the other abstraction of knowledge graphs is to focus more on the concept. And because if you find yourself saying, hey, I can't, in my environment, I can't put Neo4j or Janus or Tiger, but I have Stardog. Whatever I'm going to show can be done in Stardog, right? Now, having said that, database internals matter. They do, but not for 90% of use cases, right? When you traverse the graph, all of these things can come into play, but they do matter, but not for a lot of the use cases. So I just want to put that qualifier on there. Okay. What's the application that I wanted to tear down? It's Zotero. Now, Zotero is a citation management tool. I'm still surprised because when I started using it like 15 years ago, it was all in like uni students and people writing theses and all of that sort of stuff. I mean, like I was just checking the numbers like recently. I still use it, and it's still very, very popular. It's a really, really beautiful tool. And one of the reasons is because it's got all of these connectors that is built up over the years. It's so easy to ingest all sorts of things. And the problem that I've had with Zotero is that the search is not that great. The search is not great. It's got the Lucene full text search index underneath it. But whenever I'm searching, and I've got like thousands of over the years that I've ingested into Zotero. The problem that I've had is that whenever I say, oh, can you tell me, for this particular subject, what were the top search results? I mean, like, I have no control of it. So I want to improve that search experience for myself. I want to add on this whole thing. I want to control. I want to have control over the tags, how I weight the tags, all that sort of stuff. So that's kind of like what I want to build. Again, just the schematic of what I'm trying to do. So like Zotero, you can pull in content from all different sources. It comes into Zotero. I want to take it into a knowledge graph, organize my tags and my content, and have like ontologies and all of that sort of stuff, and that powers the search. And what I want to do is build a little plugin for that. So the problem is this: Zotero is built. It's open source. It's built over 15 years, and I don't know where to start. This is it's like, where I want to build this little plugin, but I've got this huge code base. Where do I start? You can go to the documentation, and that's lacking, as we know. So I'm starting at ground zero. I've got these questions: how and where is the data kept? How does the code base work? Any frameworks used? What does the data model look like? All of these questions, right? How does the application talk to the database? How do the functions and parameters look like? I mean, how? This is like, basic stuff. And this is like coming back to the first thing, right? You walk into your code base and you don't know anything. So how can I do this quickly? Here's the thing. First takeaway, right? No one knowledge graph can answer all questions. We're actually looking at 3 different types of knowledge graphs. The first one is a data knowledge graph. That's for database schemas. The application knowledge graph, that's for application code. And what I have is the business domain knowledge graph, and that's just like, ontologies and so on, so forth. Each knowledge graph takes metadata from different sources for each of these, and I'll show the diagram. So for the data knowledge graph, you've got the data from your data store, database, data store, whatever, right? You're picking up the schema, you're popping it into the schema, gives you the metadata, to which you pop into a graph data model, and that becomes your data knowledge graph model. On the application side, you're taking the application code, you are using a parser to extract functions, parameters, imports, all of that stuff. By the AST is for abstract syntax tree. This is the parser, is the tokenization of code just before they send it to the interpreter or the compiler. And then, so for JavaScript, you've got a JavaScript parser. For SQL, you've got a SQL parser. For Python, you've got a Python. For C, every language has got its parser. That's the only way that, just before it gets compiled into machine code, it has to go through this. So there is already a way, even if you don't know what the function names are, you can go through the parser to pick up what they are, because the parser already knows what's a function, what's a structuring. Now, the second piece that you need, the other piece of tooling that you need, is you use what you call lexical search, because once, okay, to give you an example, right? So in the standard HTML in a website sort of thing, it's pulling a JavaScript, in the HTML. So sure, you can pass a JavaScript file, but then once you know what the JavaScript file is, you also want to know, oh, that particular JavaScript file has got all of these functions. In which HTML document does that exist? For that, you need to use lexical search, right? Lexical search is just your Control F. That's all it is. It's Control F on steroids. Then you pop it into what I call, so I call all of that like the application code knowledge graph. Once I know exactly which functions and how the code base is connected, or the application code base is connected, I can then start to say, oh, I'm only interested in these connected dots. and then I can, if I wanted to, I can throw it into the LLM to give me a natural language explanation of what's going on. And finally, this one's a bit more of the where everybody's kind of like talking for the last couple of years, you know, with the advent of ChatGPT and the like. It's like, you know, talking to text. So for the business domain knowledge graph, you're taking some text, you're chunking it, extracting some entities, throwing an embedding model, comparing that to an ontology for ontology checking, and then you're popping that into a business knowledge graph. So when you tie it all together, right? So here's me. This is I'm walking up and down the stack all the time. I'm starting, you know, with a business problem, right? I'm taking content, I'm reading it, I'm tagging it, but then now that I want to improve the search capability of Zotero, I'm going through the application. I want to see where in the application code is the knowledge, are the tags being handled, and then for the application code, where is it putting it in the data? So I'm going right all the way down to the stack. Right. Let's see. Here's the thing. So just focusing on the starting with the data knowledge graph. For relational databases, right, the schema and the stored functions hold the key. So Zotero is a SQLite, holds SQLite as its database. And what I want to know is where are the tags in the database actually located for each piece of content. So for that, I need to know which table holds the tags, which table holds information about the content and its hash storage, and how are the tables connected. So I need to understand the schema. How do I do that? Here's the pipeline to ingest the metadata from the SQLite of Zotero into Neo4j, right? So you're taking the SQLite master is the information schema for the information schema equivalent for SQLite. The foreign keys are all stored in a pragma function. So I'm joining two pieces of information. I can take some stuff from the schema, and then I'm going to join it to the foreign key list, and then I have a foreign key table, and with that I can then pop those two pieces of information into Neo4j. Right, demo time. I just want to show you. Okay, I think I still got Zotero. Okay, if you want to know what Zotero looks like, that's exactly what Zotero is. It's just it's got all that sort of stuff, but I just need to close it. Okay, because otherwise. So, as you can see. So there you can see. So that's the result. I've just read the schema, and it's telling me it's got 84 indexes. This piece, I'll just say. 61 tables, 12 triggers, and that's all. So it's a very simple database. 61 tables. We say, oh, it doesn't sound that complicated. Wouldn't take anybody. Why we're doing it. I'll come to that point in a minute. So once we ingest all of that thing, right? As I was saying earlier, we ingest all of that into Neo4j. I just want to show you what you end up with. I'm not going to go through all of this thing. When I pop it into, this is the schema of Neo4j, right? I said, I've got all the tables, and I say, all the tables from all the table names. This is metadata only. No data has come across. I've just read the schema of Zotero. I've got tables, all the columns, and how they are joined. And I've got three different types of relationships, right? The parent foreign key, child foreign key. Which one's the foreign key? Which one's the source column? And this hash column is just another another type of relationship. I can call it, it's still just only one, but I can call these relationships anything that I want. So that's what it looks like when when it comes into Neo4j. Okay, great, wonderful. So how does all of that help me? So if I wanted to find, there's a table of tags, and if I wanted to find how I can join it to the table items, that is the join path that I use. This is the code that I needed to throw into Neo4j to show exactly, can you tell me what is the shortest path to join tags table to items table and return the path. So that's the code, that's what I needed to generate that piece. So just let me just refresh some of this stuff. Yeah. Now I've got everything in there. See, I've got all the tables in here. What I've got, remember, what I've got in Neo4j is only metadata, right? But I can now use that metadata that's in Neo4j to power SQL to go and get actual data from the database. So let's say if I wanted to see deleted, oh, I don't think I've got anything in there. Let's say I don't, fields, have I got anything? Yeah, look. So that's just gone me the first 5 rows of the fields. This is a if you look at the code here, it's just Neo4j that's powering the SQL to get me the actual data. Same thing here. If I wanted to find, how do I join, let's say, this base field mappings to, let's say, collection field. Let's say, okay, those are the 2 tables I'm interested in. All I need to do is just run that. There. It's given me, if you want to go from base field mappings to collection fields, that's your shortest join path, right? All of this is coming from Neo4j's metadata, and it's powering the metadata, which then says, okay, I've got all the connections, all the data, all of this stuff, and you've just asked me for the shortest join path, and I've linked it all. So you can say, from here, I already know what is my SQL that I need to do. I need to do base field mappings to item data via the field ID column, same item to item relations thing. Now, in the interest of time, I am just going to say, this is one of the reasons why now. So, key takeaways from here, right? Here, I'm reading the metadata, the schema from the relational database. I don't rely on any documentation. I don't have to rely on updated, someone doing entity relationship diagrams or anything like that, and then just kind of like navigating all of that through. I don't know anything about the data model. I can ingest everything from the, as I say. You just saw the few lines of cipher that I wrote, saying shortest join path, and stick in the 2 table names, and it pops it out. And I've got this functionality, right, is so powerful, and I'll tell you why. So I just finished a gig in, this is my second gig at NBN. Now, last year I was there, and my job was, NBN was going to replace its ERP system. They were in Oracle EBS, and they were going to go to SAP for HANA. And what was my job? It says, oh, it's a very complex data model. It's an ERP system. Oracle EBS has 24,000 tables, and they want to go to SAP for HANA, which has got 20,000 tables. Do you know what Accenture was going to, just to do that mapping? 20 million. And how do they do it? They got some friends in offshore, our offshore partners who do it. Millions putting up on the wall, doing all this stuff. To ingest the schema from Oracle EBS into Neo4j is only 1 day. And I can say, whatever you want to do, I can do it. That's the power of putting a knowledge graph for metadata on top of your database. That's the thing. We're running. Now, what I've got here, I probably won't go through this whole preso, but the notebook is all up there. What I wanted to do is just very quickly go through the trick for the application code how I ingest the application code metadata, right? First piece that I do is like I'll query the repo is held, the Zotero repo is in GitHub. So I'm going to query the GitHub repo. I'm going to traverse down the entire directory. And the first thing that I need to do is to get all the file types and see what am I dealing with. Because I need to know the file types, whether it's JavaScript, is it Python, is it C, whatever. Because before I can put the parser, because I need to know which parser I need to do. Right? And then I can then start to build the knowledge graph on top of that. So this is the stats from the Zotero repo. I can see this SVG. Okay, so some UI assets in there. That's 22%. I can out of all that. So there's free market. Those are template type files. Those are not particularly interesting. But it is the JavaScript that I know holds the application logic. So what I'm using is I'm going to extract all the functions. Remember, I don't know anything about this. I don't know which functions, I don't know anything, but the parser does. The parser will traverse down every JavaScript file and say, that's a function, that's a parameter. It knows everything. And I'm going to take all of that and then pop it into the knowledge graph and shows me all the connections. And I'm going to do a quick demo. And then once I know, right, which of the JavaScript, I want to know in the HTML, in the template files, where is this function node? So I am now building a search tool, just ingesting all that metadata into Neo4j, where these things are connected. So that's how I'm building the thing. Now I'm interested, in the interest of time, I will just say the final piece of this is that once I have the entire code, and remember this is fact, right? This is deterministic. There's no probability associated. Could it be wrong? This is because this is what the interpreter and compiler see. Right? This is fact, right? The knowledge graph is based on fact. Then I know that I can then write queries against the knowledge graph and say, okay, for this particular function, right? I can then throw it into the LLM and say, can you now explain this to me, right? I think the other more powerful piece is, I just want to show you, I just ingested that, right, yesterday, right? And this is what the application code knowledge graph looks like, right? So I've got files, there's import functions, call functions, I've got everything in there, you know, however I want to saying, okay, can you tell me, which functions, have got the most parameters, and I can search that way. Key point, key point. Remember, the knowledge graph only has metadata. It will run to the repo. GitHub has got a job, right? And that's to hold it. The metadata is only to power the search query on that. So I think that's probably the main, I mean, look, there's a long story towards all of this, but that's fine. Let me just very quickly, I just want to wrap it up there, say thank you to the one who connected my code base. Your Bitcoin's on the way.